Schema Registry and Protobuf can make your pipeline smarter, faster, and far more reliable. But let me ask you this. Why does JSON break at scale? What is this format that big tech uses to shrink their data and catch schema issues early? And how do teams manage it without constantly breaking their pipelines? At Netflix and Uber, millions of Kafka events flows every second. But at scale, JSON become bulky and error prone. Stick around. By the end, you won't just understand Kafka, Protobuf, and Schema Registry pipelines. You will know how to build, scale, and fix them like a pro. Let's break this down. Say you are building a food delivery system like Zomato or DoorDash. Every time a user places an order, an event is published to Kafka topic, something like this. This order placed events consumed by multiple streaming systems like the fraud detection system that might be written using Python and Spark, delivery ETA service may be running in Go, customer notification service might be running in some different language like Node.js, accounting and invoicing maybe that's running in some other language, Java. Each of these consumer parses the same JSON event in their own language. JSON is flexible, human readable, easy to start with. But that flexibility become your enemy in the production. It's verbose. Every field repeat per message. At scale, that's gigabyte wasted. And worse is it's schemaless. If one producer changes a field name or adds a new field, consumer breaks. And debugging that in real-time system is a nightmare. Imagine one day a developer rename customer ID to cust ID. Another adds a new field. A third accidentally changes the type of amount. Now Spark failed to parse the schema. The Go service silently ignores this missing field. Java throws a runtime exception. Dashboard breaks and no one knows why. JSON doesn't enforce a contract. There is no guarantee of what structure is expected. No versioning, no type checking, no warning. You are flying blind. And imagine in large teams, this break things fast. You realize your biggest issue is not Kafka. It's not Spark. It's this. You don't know what your messages are supposed to look like. And your consumers are just guessing. That's when you start thinking, what if producers and consumers agreed on the message structure and the structure was enforced? That's where Protobuf enters in the picture. So what is Protobuf really? Protobuf is short form of protocol buffer. It is a language-agnostic serialization format developed by Google. It replaces loose, unstructured JSON with something far more powerful. A well-defined version contract, something like this. This .proto file is the source of truth. It defines the schema, the exact structure, and data types of your Kafka message. From this file, you can auto-generate code for Java, Python, Go, Node.js, Rust, and many more other languages. That means producer and consumer in any language can talk to each other safely, efficiently, and consistently. Protobuf is faster, smaller, and safer than JSON. It's made for real-time, high-scale system. That's why Netflix, Uber, and Spotify uses Protobuf across their pipelines. Now you might be thinking, how is the flow? The producer takes the data and serializes it using the .proto definition. It sends a compact binary payload to Kafka. The consumer needs the same .proto file to deserialize that binary back into usable data. This gives us speed and structure, but introduces a new challenge. How does this .proto file get shared across different consumers? How do all consumers stay in sync? What happens if the producer update the .proto file, but some consumers are still using the old version? In theory, you could put the .proto file in GitHub and tell every team to keep in sync. But in real-world data platform, with dozens of producers and hundreds of consumers, that's a ticking time bomb. If a consumer uses an outdated .proto deserialization breaks, or worse, the data looks fine but it's wrong, so what is the solution? You need a central system that stores every version of your schema, ensures producer and consumer references the correct one, that supports compatibility check before deployment, and allow consumers to dynamically fetch the schema when processing data. That's where Schema Registry comes in. Think of it as a central library of schemas, where every version of every Protobuf schema is stored and versioned. When the producer serializes a message using Protobuf, it registered the .proto schema with a schema registry. The registry returns a unique schema ID. The producer embeds that schema ID along with the binary data in the Kafka message. Now here is the magic. When a consumer, say a Spark structured streaming job, reads the Kafka message, it extracts the schema ID from the message. It contacts the schema registry and asks, hey, give me the .proto for the schema ID 42. The registry returns the exact .proto file. The consumer deserializes the message dynamically with full context. Let me show you what that structure looks like and why schema ID is the key part of it. Every message sent by the Kafka when using schema registry starts with a structure like this. First byte is the magic byte. Next 4 byte is the schema ID. And after that, everything is the actual Protobuf data. So, why do we need this structure? Because the consumer receiving the data has no idea what schema was used until it sees the schema ID. The schema ID tells the consumer exactly which schema version to fetch from the schema registry to decode the message. Every time you register a new Protobuf schema in the schema registry, it assigns a unique integer ID. When the producer serializes the message, the serializer checks if the schema already exists in the registry. If yes, it gets existing ID. If no, it registers the schema and get a new ID. That ID is then embedded into the message right after the magic byte. Have you ever wondered how Kafka consumer know what schema to use without you explicitly sending a .proto file? That's how schema ID message points directly to the schema in the registry. This is why consumers don't need the .proto file manually. They use that schema ID to fetch the exact schema they need. Back when we said we need a single source of truth for schemas, this is it. The registry takes our .proto file and tracks its version by version. In our consumer code, we created a Kafka Protobuf deserializer and passed it the schema's registry URL. Behind the scene, the deserializer reads the schema ID from the message, calls the schema registry to fetch the schema, and deserialize the message into a usable order object. That's how Kafka plus schema registry plus Protobuf makes producer-consumer communication schema safe and language agnostic. Now you might be thinking, wait a minute, if every Kafka consumer has to connect the schema registry every time it receives a message just to get the schema, wouldn't that create a lots of latency? That's a great question. And the answer is no. Thanks to intelligent caching. When a Kafka consumer, like a Spark job or a microservice, receives a message, it first reads the schema ID embedded in the wire format. If it's the first time seeing that schema ID, it reaches out to the schema registry, fetches the schema, and store it in the local cache. For all other subsequent messages with the same schema ID, the consumer simply reuses the cached schema. No network call needed. This means that even in high throughput environment, your consumer only experience a tiny delay on the first message per schema ID. After that, deserialization happens entirely in memory at near zero cost. So far, we have seen how producer serializes data using Protobuf, sends it to Kafka, and the consumer deserializes it using the schema from the registry. But in real world system, the schema evolve. New field get added as business grows. This flexibility is critical in modern data system. You can roll out new fields in stages. Old consumer won't break. New consumer can take advantage of richer data. It's safe, versioned and schema driven. Thanks to Protobuf plus schema registry. This completes the end-to-end flow, JSON to Protobuf to Kafka to schema registry, deserialized back to JSON using Spark. If you are building something similar or stuck anywhere, drop a comment. I'll read and reply to as many as I can. And if you have done Protobuf with Spark before, I would love to hear how you structured your pipeline differently. Hope this gives you a solid foundation on how to use Kafka with Protobuf and schema registry in real-time Spark pipeline. So, if you are serious about building resilient, scalable Kafka pipelines, Protobuf and schema registry are not just nice to have. They are non-negotiable. No more guessing what your message look like. No more silent failure, broken consumer, or debugging nightmares at 2 a.m. Instead, you get fast, compact message with enforced contracts and a centralized system to manage schema evolving without breaking anything. This is how data moves reliably at companies like Netflix, Uber, and Airbnb. And now you can bring the same power to your own pipeline. Protobuf gives you the structure, schema registry gives you control. Together they give you peace of mind. If this helped clarify how it all fits together, hit a like and share it with your team. And if you want more real world data engineering deep dives like this, you know what to do. Subscribe to the channel. See you in the next one. Till then, stay curious and keep building cool stuff.